Hello friend. In my last video I showed you that how did I manage to convert the string data into the numerical representation with the help of level encoder. Now it's the time when we have to split this entire data set into two segments, and that is called independent features and dependent feature. So which are the independent features? Age, student, income and saving. These four columns, or I must say these data frame is actually considered as independent features, whereas by book column, which is a single series, is a dependent feature. Now how do I do this, or how do I consider the split operation? And for that reason I have made some modification in this particular function. So let me evaluate the entire thing, and before that let me run this particular statement. Let me save the file and let me refresh it to show you that what output you are going to evolve. So this is the output what you will be getting, and here if you notice the first four features I have split it in separately under the X, and the last feature or the label I have separated under Y. So this is the output what we need to deserve. So how are we able to achieve this? So as we are seeing that in the last video also I stated the label encoder I have to work on. That's the reason this transformation has taken place. And to show the actual categorical data, so this portion I have to keep this particular variable reference intact, and I have generated the output right over here with the help of the to HTML. Now comes the portion where I goes for the conversion of the string to the numerical form using the label encoder fit underscore transform. This particular segment went on, and here is the transform data which I have to print right over here, and because of which you are getting this particular data frame. Now let's come to today's topic. The first and the foremost thing is that I need to split this data set into two parts. The first part would be the independent features. And how do I do this? And for that reason I will be making use of dataframe.iloc. We know that iloc is used to identify the specific indexes of the features, and accordingly we can go for a split. So I need to take all the rows, and I need to start extracting from the 0th column till the n-1. That means the by book column will be out of the range. And after I have fired this line, as we know that we are working on data frame, so you would be expecting that this particular reference would be of also type data frame, but the answer is no. As you can see, it is of type ndarray. So after extracting iloc, the resultant output will be stored inside the ndarray, and I can even show you that. Let me just write this particular line over here, and let me execute this statement. So let's come and run the code over here. And as I do that, let me bring you the terminal. You can see the data over here is in the form of a numpy array. So remember, for the fresher who would be doing it for the first time, this is a place where often people get struck. So for that reason, you have to be very careful that when you are extracting data through the help of Pandas DataFrame, the resultant output will be in the form of a numpy array. Henceforth, you need to fire this particular statement to convert your numpy array into Pandas DataFrame. So for that reason, you have to write pandas alias representation, which I have written over here, pd. So pandas.DataFrame, and which particular numpy array you want to convert, that you will write as the first parameter. And second, if you notice over here, you are passing a list of columns, because data frame is actually double dimension matrix presentation. For that reason, you're writing age over here, then comes student, then come income, then comes saving. So these are the column that you are going to put forward over here, and be very careful, it is in the plural form because data frame is expecting multiple features. That's the reason it's in the plural form. And after doing this, you will be getting the resultant output in the form of a pandas data frame. So you can just go and run this particular code. The first one would be in the form of let me show you the output. The first one would be in the form, oh, I didn't refresh it. Yeah, the first one is in the form of a numpy array, and then you have got something in the form of a pandas data frame. So that's how this particular statement is working, right? So far so good. Okay, so now what we have to do, we have extracted successfully the features. Now we have to go for extraction of these. So let me comment these lines, otherwise it might create some confusion. Yeah, and now what we have to do is we have to go for, okay, one more thing I want to show you, that before I converted this particular numpy array into data frame, how exactly the output would look like. So for that reason, what I will do is that I will fire the print statement over here, and once you see the output before the conversion, it will make the thing much more clear for you, and you will understand that why it is so important. So let me refresh the page and look over here. This is what the output I was talking about. This is how a numpy array represent. Look over here, this is the first starting index, and here the index ends, I mean the array ends, and each row has and these are the each rows, so it's considered as a one single array that has got multiple rows. And this is how a numpy array would be represented, but this is not what we want, because we want a data in the form of a column representation as well, where we will be having individual features. And for that reason this conversion is very important. Okay, so I showed you, and now once you have converted it, here you can see the difference. So again, let me keep both the statement and let me refresh the page, and now you will be able to figure out how they are different actually. So let me refresh it, and now look, this is what the initial numpy array is. And after typecasting, this is how the Pandas data frame actually looks like. And this is what very important, because over here you have got the row index, over here you have got respective features as well. And this is what you need, then only you will be able to store the data in the HTML page, I mean the browser as well, using Django. Remember, this whole thing I'm showing it in Django, not just in Jupyter Notebook or in Colab, because after all, at the end of the day, you have to give the output to the, I mean your program to the client. So for that reason, you need to have a very flexible interface. Okay, so let's come back to the code once again. So let me comment these two portions, and I have shown you the why the typecasting was so essential. Now I'm going for the independent feature. Once I am going for the independent feature, you are just going to get one particular column, and this is also going to generate the same output. It will be in the form of a numpy array. You can just check it out. I'm commenting these things just to save some time. Now we all know that this particular output is just going to have only one column. So is it right to call it as a data frame? Actually no, because it's a one single column that has got multiple rows. So for in context to Panda, we call it as a series. So what I have done is that I have created, I have converted this numpy array into series, and I have stored it over here. But the problem would be that if you are passing a series to HTML, that will actually not work. Okay, so for that reason I have to convert again this series back to frame, so that it can be used as a Pandas data frame. Okay, but just to check out the output, that how exactly it looks like, you can do one thing. You can just write pies wide underscore series. Just I want to show you the output, that how exactly it looks like. And let me refresh the page, and as I do that, now see over here you have got, see, this is a series, but you still have got individual index for the row wise. So this is one single column, and each representation of the row has been done with the index wise. So that's how a series would look like. And after transforming, I can again print the output over here. So let me show you how it looks like after transformation. So it will be Y, and now let's run the code just to differentiate between the first and the previous one. Now see over here, this was not having any column, the label was not there, but I have gone for the label. So look and feel is almost the same, but internally this has been converted into our data frame, and that's the reason why I can pass the data frame right to the HTML page. So as you can see, I'm passing this Y, I'm typecasting this data frame into HTML table, and eventually I'm able to show you the dependent feature or label as well. Okay, so that's how we saw that how we can extract the features which are independent and the feature which is dependent. And this is very much essential, because in my next video I will be going for the split and train, where I have to split this entire data set into two segments. The first one would be the training data set, and the second one would be the testing data set. And while doing so, you need to have a separate features and the separate labels. Okay, that's what will be the content of my next video. I hope you like this particular video, so keep watching. See you soon.